Today I am continuing my series on solving some of the hardest mathematics exams from across the world, and today we're looking at the Jee Advanced paper. Let's get stuck into it. Hi everyone and welcome back to my channel. For those of you that are new here, my name is Ellie and I'm currently an astrodynamics software engineer and I'm a Cambridge mathematics graduate. And we're continuing solving some of the hardest mathematics exams from across the world, and today I'm doing a paper that has been highly recommended, and that is the Jee Advanced paper. Now this is the paper from 2016 and it is considered one of the hardest papers ever sat on the Jee curriculum, and we're focusing on the mathematics section of this exam. So yeah, let's get stuck into it. Okay, awesome. So you are on my screen here and I'm just going to go through the entire solutions for this paper. I have already answered the paper and I'll be showing my solutions and just talking you through how you would go about solving some of these problems. So the first question says, let P be this 3x3 matrix here and I be the identity matrix of order 3. So we know that both matrices here have the same order. And then we have let Q equals this, and that is a matrix such that P to the power 50 minus Q equals I. And then we want to compute what this value here is, and it gives us some options. So we want to go about figuring out what this quantity is here. Okay, so first things first, we write down what P equals. So this is what P is here, and we can just do some simple matrix calculations and calculate what P squared is, and then we find it's this value here. We can calculate what P cubed is, find it's this matrix here. And what we can do is we can compare, you can extend this to a higher order, so if you want to do P to the 4th, you can do that. But what you'll notice here is there is a certain pattern occurring every time you multiply by the matrix P again. And the pattern that arises means that we can write P to the power n as this matrix here. So as in the question, it asks us for P to the 50, which is this here, and we can calculate that because we just sub in n equals 50 into this matrix here. So now that we know what P to the 50 is, we can look back at the question and it tells us this here, that P to the 50 minus Q equals the identity matrix. So we can rewrite that in quite a nice form, and that's given by this here. So all you're doing is you're substituting in for P to the 50. You can write Q as a matrix, kind of a generalized matrix, which is given by this here. And that just means you don't actually know what the values of Q are because you're being asked to calculate them, but you can write it in this form here. And we know that the identity matrix is given by this here. And by comparing the values in the matrices, what you can do is you can calculate Q31, which is this quantity here, Q32, which is this one here, and Q21, which is this here. And that's just by doing some equations as seen here. And then all you need to do is, once you know those values, compute this here, which is what they're asked in the question, and you will find that you get the answer 103. So that is B in this question. So as first questions go, I thought that was quite nice. Wasn't too hard, quite a nice question. Now we move on to the next question. Now this is basically using a manipulation of trigonometric identities. So we have here the value of this summation here, and we need to calculate that, saying it's equal to one of these values, which one is it? So we can look at this straight away and notice that the denominator has two signs multiplied by each other. And if you remember from trigonometric identities, you can write the multiplication of two sign values in the form of this here. And essentially all you do in this question is you just calculate what the denominator is. In this question, you can rewrite it in the form that I've just mentioned, then do some simplifications, which can be seen here. And then once you've done that, all you need to do is really look at this value for cos here and evaluate what this value is for the different k values. And once you've done that, you arrive at the value 2, open bracket, root 3 minus 1, close bracket, and that is number C. Letter C, should I say. I'm getting too involved in the mathematics here. But this question itself was it's definitely more tricky compared to the first one. The first one I thought was really, really nice. This one means you have to remember a lot to do with trigonometric identities and just remembering certain values of cosine and sine at different values. Now, I'm not actually too sure whether you get a formula sheet in the Jee Advanced. I'd love to know, so if you comment down below, let me know. But we'll move on to the third question. Let b I, or subscript I, be greater than 1, for I from 1 to 101. And we have supposed that log base e, b1, multiplied by log base e, b2, all the way to log base e, b subscript 101. They are in arithmetic progression with common difference log base e to e2, and we suppose that the series a1 up to a101 are in arithmetic progression such that a1 equals b1 and a51 equals b51. And then we're saying if t is this series of b's up to, the addition of b's up to b51, and the same for s, but for a's, then we have some conditions that we need to deduce. So the first thing we can do is we can look at the condition, which is, suppose that, I'm just going to underline it, it's this condition here. We're saying that this is in arithmetic progression with common difference log base e equals 2. So what you can say straight away is this condition here. I've also just realised here that I started writing the natural log here, which I shouldn't have done. I should have just put log e here just to be consistent. So let's just rewrite that just to be consistent with the question. But yeah, so this is what we can find from that condition there. And then from that, you can do some simple mathematics and just solve this here, like I've mentioned, and then consider different b values in order to get a condition. And what condition we get is this one here. So that's from the first. Now we are looking at this condition on t, and we know that this t series here, or this addition of b values, we can rewrite using the condition that we've just arrived at, which was this one here. And from there, you substitute these values in, and what you find is we get this series here. Now, if you look at that, you'll notice that is a geometric series. And using the equation for geometric series, you can rewrite t as this quantity here, which is great, it's simplified. And you can do something similar for s as well. Now, s is obviously is a series in A rather than B, but we notice that this itself is a arithmetic series. So we can use the formula for that, which is this here, and we can arrive at this value for s. So we found the value for s and t in a very nice simplified form. Now what we'll do is we're going to use the condition that a1 equals b1 and a51 equals b51. And using that, we can do some simplifications, which are these here, and we can use that condition and substitute in the values for b, values for a into s, so we can write s in terms of b, which is this quantity here. Okay, now in the question there are a few different things you've got to consider. It's asking you to find out if s is greater than t or if s is less than t. So now that we know what the two values are for s and t, we can figure that out. So what we do here is we just simply take s minus t, which is here, and obviously we've rewritten s in terms of b, so this simplifies the calculation a lot nicer. And once you do the calculations here, you find that s is actually greater than t. Okay, great. So we know that it's either going to be a or b. Now we need to consider this final part of the question. Is a101 greater or less than b101? And the way that we do that is just by noting what we found earlier. So we can write this here, and that's just from this here that we found. So we can write that. We can also write an equation for a101, and then all you do is you just do some simple calculations here, and you deduce that b101 is actually greater than a101. So therefore the answer is B. Awesome. So this question itself was on arithmetic and geometric series. I must admit, I kind of remember doing this in kind of GCSE and then A-level, and then it never kind of cropped up ever again in uni. It was kind of strange. Like I really enjoyed it, and it was quite nice to have this question because I was like, oh my gosh, I haven't done this in literally ages. So yeah, it was nice for me to kind of have a bit of a refresher on this question. But the question itself is it's a nice question. There's a lot to it, so you have to really separate it piece by piece. All in all, I thought the solution to it was quite a nice solution. So yeah, that was the third question. Now, the reason I'm going through these questions at quite a fast pace is because it's quite a long paper as the Jee Advanced. You have an hour to answer all of these questions, and with me explaining it, it might take longer than an hour. So I'm trying not to make a video longer than an hour, which is why I've written my solutions beforehand. So you can pause the video, you can look at what I've done, and hopefully it will all make sense. But yeah, I'm thinking of there is a really hard question in this paper, which I'll get onto hopefully soon. And I'm thinking of doing the full solution to that because there are there's YouTube videos online where people have gone through it and it's taken them like 20 minutes. And this part of the exam paper takes an hour. So yeah, I'm trying to get through it as fast as I can. Okay, right, question 4 I think we are on. And this was a really, really nice question. Yeah, I love my calculus. I love integrals. So the question says, the value of this integral here is equal to which one? So we need to calculate this integral. Okay, so first things first, we can do a little bit of manipulation to the denominator here. So you can rewrite the denominator here as this form. Then all you do is you input that into the denominator here. You can rewrite the integral as this here, and we're going to denote that as I. So we're saying that the integral in the question is given as I. So then we can calculate what 2I is, and that's just I plus I. And doing that, you can simplify using what we've done. We've manipulated in the denominator, which is this here, and you can get this nice equation out for the integral. And yeah, then you just do some simple calculations for the integral and you end up with the answer that is A. Okay, awesome. So that question was really, really nice. Probably my favourite question on this exam, but that's because I just love calculus, so maybe that's why. Okay, moving on to the next question. So it says, let P be the image of the point 317 is with respect to this plane, and then it says that the equation of the plane passing through P, which is the point we've just described, and containing this straight line here, is given by one of these here. So it's our task to find the equation of the plane that passes through the point given in the question and also contains this straight line. Okay, so first of all, what you do is you use the formula for the image of a point, which is given by this here. Now, once you've solved for this formula, you end up with these values for x, y, and z, which means you can then write what the plane is passing through P, and that's just using this point that we've calculated here, and that gives us this formula here. So now it's down to us to calculate what A, B, and C are. So what we know in the question is this plane must contain the straight line that's given by this here. So perfect, we can sub in some values or rearrange what x, y, and z must be in this equation. So from the equation of the straight line that we have here, you can rewrite what x is, so x equals z, or it also equals y over 2, or y equals 2x equals 2z. And then all you do is you substitute that into, let's call this star here. So substitute into star, and take these values x equals z and 2x equals y. And then once you sub that into star, you end up with this, which is just an equation in terms of x. So you can look at the coefficients for the different terms. So the first thing you look at is for x, and then for the constant value, and all this is two simultaneous equations. We know how to solve them. Once you solve them, you can get the quantities for A. So you end up with A, B, and C. So the values for those. And then all you do is you substitute that back into star, and you end up with this equation here, and that is for the plane that passes through P and also contains a straight line given in the question. So that is answer C. Okay, so I thought that question was nice. Now we move on to question, I think it's 5. I mean, it's 42 in the paper, but we're on 5. Okay, and once we've done this, we are at the end of section 1. Whew. Okay, cool. So this question says the area of this region here, is equal to, so we need to compute what the area of this region is. So the first thing that we do is we're going to look at what we have. So we have x and y is on reals squared, and then we have this condition here and this condition here. So if we work with number 1 first, and this is number 1, you can rewrite number 1 as this, and that's just by the laws of absolute values. And then you have number 2, which is this one here. So if you draw this, you can draw the lines for y squared equals the modulus of x plus 3. So you have y squared equals x plus 3, and then y squared equals minus x minus 3. They're quite simple to draw. You just got to remember what a parabola looks like basically on its side. So that's pretty fine. And then you just draw the line for 5y equals x plus 9. So what you'll notice is when you look at where we are looking at on the graph, so in this region, we have this little region inside here. Green lines in here. Okay, now that in itself is pretty simple to calculate. All you need to know is the point at which that intersects with the different values here. And once you do that, you can find that the intersection here is given at x equals minus 4. The intersection here, which is, it's an intersection, but that's quite a trivial one, is x equals minus 3. And this here is x equals 1. And how do we calculate areas under the curve? We do integrals. So all you need to know is you just write the integral, the integrals in this form here. You can verify that, but you get the value 3 over 2, so that gives us C. Okay, awesome. So that is the end of section 1. Now, I don't actually know how long you're supposed to have for section 1, so do tell me in the comment section below. So yeah, so if you got to the end of section 1 with me, then let me know how you found it in the comment section. We start with section 2. Okay, so the question says, let P be the point on the parabola y squared equals 4x, which is the shortest distance from the centre S of the circle given by this equation here, and let Q be the point on the circle dividing the line segment SP internally. Then we need to deduce which of these is correct. So the first thing to note is I just did a quick sketch when I first did this, just to kind of visualise it. I think a lot of the time visualising is really helpful. So I took the parabola, which was this here, which is the red line here. Now, what I did was I wrote the circle out here, but then I simplified it in this form, and you know from this here that the centre itself must be 2, 8, which I've denoted here, and from this we can deduce that the radius squared must be 2. Okay, now we can look at the part that says the parabola is at the shortest distance, so P is a point on the parabola which is given here. Now ignore the fact that that says 4, 4. We calculate that in a minute. I just added it on once we calculated it. What you need to know is the shortest distance is the normal to the curve, should I say, and you can write the form of a parabola, the coordinates of a parabola in a certain way depending on what the form of that parabola is. So we have this form. So what I've said is note that the normal to the parabola of the form y squared equals 4ax is given by this here. Now in our example we know that a equals 1 because we have y squared equals 4x instead of 4ax. So a is 1 here, and that means that we end up with this line for the normal to the parabola. Now what we can say is this line itself we know goes through 2, 8, and then you can just do some simplifying here and you can find that the normal is given by this. Now from this we can deduce that P must equal 4, 4, and that's just by the condition that we had here for t squared and 2t at the coordinates on the parabola. Okay, and then all you need to do is calculate SP. Now the reason we calculate SP is because it's asked in the question, so it says what is the value for SP. We calculate the value for SP, we get 2 root 5, which is exactly what it says in the question, so A is correct. Now it says calculate the ratio for SQ to QP, and once you do that you just look at the graph, you kind of look at the plot, note what the quantities are, and then you get a value for this. That is not the value given in B, so B is not correct. So for C it says the x-intercept of the normal to the parabola at P is 6, and all you do is saying the x-intercept, so you set y equals 0, and then from star, which is given here, we can calculate what the value is of the normal, and we find that x equals 6. So C is correct, and then D says the slope of the tangent to the circle at Q is a half, and what we look at, typically if you're looking at tangents and the slope of a tangent, we know what the slope of the normal is, and that's here, that t is minus 2. I'm not sure why I've put minus t. I think it's just t is minus 2. Okay, yeah, t is minus 2 here, and then of course it's the reciprocal inverse, it's the inverse of the normal negative, so the slope of the tangent is indeed a half, so D is also correct. Awesome, so that is that question. Again, I thought that was really, really nice. So we have this unit vector here. We're told it's a unit vector, and we have this equation for omega hat. It says given that there exists a vector v such that u cross v modulus equals 1, and this, which of the following statements are correct? So the first thing that we can know is we have that omega hat is perpendicular to u hat cross v, and that's given, and that's because of this equation here. And then we know that w must therefore, I think I've used w here, but I meant omega. Well, omega and w are interchangeable here, so just excuse the fact that I've written w instead of omega. From the condition given here, it must be true that w hat equals u hat cross v. And that's just by the laws of cross product in this case. So therefore we can say, okay, what are we told? We are told that w hat, I'm just going to call it w hat for now because I've used w in here. W hat is given by this formula here, and by what we've just calculated, we can say, okay, u hat cross v hat. I think v hat is supposed to be a vector here. I think there's some notation that's just a little bit inconsistent, so apologies for that. But we're told we can deduce this, and then all you do here is you say, okay, we want to figure out which statements are true. So we know that there exists a vector v, so we can write it in a generalized form for x, y, and z for the different components. And then if we do a little cross product in here, so we know that u cross v is given by this here, we're just doing the cross product, and that equals this. Then we can deduce, okay, we just do the cross product for the terms, the general terms, and we arrive at this system of equations here. Now, from this system of equations, we can deduce that the determinant equals 0. And the reason for that is we can write this system of equations here in this format, and when we do that, what we know is the matrix is skew symmetric, and because it's a 3 by 3 matrix, that means it's odd, and from that the determinant must equal 0. So we're just going to continue and look at dx, dy, dz here. Now if you remember, the formula for dx is given by this, which we can substitute in here, and we end up with this value here for dx, and then we can do the same for dy and dz here. In the question we're told that there always exists a vector v, which means there must always be a solution. However, because we have shown that the determinant equals 0, it means that there are infinitely many solutions for this vector. So that means we have b is correct. So there are infinitely many solutions for v. Okay, now the reason we looked at the dx, dy, dz, and that's just because of these last two questions here. So it's saying if u hat lies in the xy plane, then we have a condition. So what we do is we say, okay, well, we know that the determinant equals 0, which must mean that the dx, dy, dz must also equal 0. And from that, we can look at the common factor in all of these dx, dy, dz, and that's these here. And of course, d will equal 0 when this is also equal to 0, so we arrive at this condition here. And if we just look at when we're in the xy plane and the xz plane, all we need to do is just remove one of the quantities. So for the xy plane, we just remove the z contribution, so that's u3. So we arrive at this here, so we end up with c. Now again, for the xz plane, we just remove the y contribution, so we end up with this formula here, but that is not consistent with what it says in the question for D. So it's not D. So for this question we have B and C as the solutions. Okay, cool. Now the next question, which is actually quite nice, says this. So we have A and B as some quantities, we have a function, and it's defined by this here, pretty nasty looking function. Then it's asking us to deduce some conditions on F. So now this one's quite nice because all you would need to do is look at kind of the symmetry of cos and sine and x. So the first thing to note is we know that cos of minus x equals cos of x, and by the conditions for the absolute value, that means that we can rewrite cos of the modulus of this quantity as this here, which is nice. And again, if we look at x sine, so we have modulus of x and then sine and modulus of some value inside, which is here, we can write that is equal to this. And the reason for that is because you can look at the modulus of x, which is given by this here. You can look at the sine of the modulus of x, which is given by this, which therefore equals this. And then when you multiply the two together for the different sides, you end up with the same value, which gives you x sine x. So you can rewrite f as this form here, and we know that this is differentiable. We know that these functions are differentiable, so we can deduce that the solutions to the question are A and B. Okay, cool. So this question is one of the hardest questions anybody has said has happened on the Jee Advanced Mathematics exam. The question itself was really, really nice to get going. It reminded me a lot of kind of statistics, and I'll get into it in just a second. But I'm going to be kind of skipping over some of the kind of long calculations in this, because I'm going to do it in a separate video, because I want to explain it fully. Okay, so we have this limit, this crazy, crazy limit here, and we need to calculate some values. So we need to know kind of what the value of f is at certain points and also what the derivative of f is at certain points. So the first thing you do is, I've just written it out again here, and you can look at the terms in the limit and you can notice certain things about them. So we can rewrite this limit, it's a bunch of multiplications. You can rewrite the top as this here, and then you can rewrite the bottom as this here. Now, something to note in the question, I've just moved this n to the n down here because it doesn't play any factor in this summation here. Now, obviously we have this power here. What do we do when we have powers? We take the natural log. So we've taken the natural log, as can be seen here, and nothing really changes other than the x over n comes out to the front here. So we can multiply by this here and note this formula for a log of a product, should I say. I think I said summations in here earlier, but I meant products. You can look at the relationship between the summation of a log and then the product of a log. If you can remember this here, we can rewrite it in terms of a summation instead of products. And then if you look at what we have here, we have the limit as n is tending towards infinity of 1 over n, and then we have a summation of this product here. And all that is an integral, because we kind of, if you can imagine the area under a curve, and we have 1 over n, and then we're summing these values, it's essentially just an integral, and we can rewrite that as this here. We know that this was the log of f of x is this. So we've managed to deduce this huge limit into a really nice form, and then using a change in variables for this integral, we end up with this form of the integral here. Now in the question, it asks you to compute some values like these here, which is f prime over f. Now to calculate f prime over f, you just note that we have this here, and using the Leibniz integral rule, I believe for this question, you find what the value is for f prime over f. All that's left in the question is actually really, really nice. We just look at this form and then evaluate on different x values. So we know that for x between 0 and 1, we know that the log of 1 plus x is greater than 1 plus x squared. So therefore f prime from this here must be increasing. And then if you do the same for the range up to infinity, it's decreasing. So we know that B and C are correct. Now, the final part of the question asks you to evaluate f primed 3 over f3 and see if that's greater than f prime 2 over f prime 2, as seen here. And if you do that, you just add in the values and you have log of 2 over 5 and log of 3 over 5, so it's not D if you evaluate those two sides. Okay, so this question just gives you B and C. Cool. Okay, we are on to question 47. All it's saying is that we have a function r and a function g. They're both twice differentiable functions. We're told that f double prime and g double prime are continuous functions. We are also told that f prime at 2 and g at 2 equals 0. It says if this is true, so if the limit equals 1, then what happens? So first things first, we just write down what this limit is, given by this here, and we can just sub in some values. So we are given that f prime 2 and g of 2 is 0, and when you plug that into here, we end up with 0 over 0. So we know we have to use the L'Hopital's rule. So if we use L'Hopital's rule, we just have to differentiate the top and the bottom, which gives us this form here. Now we are told that g of 2 equals 0, which is why we remove it in here. And we're told that f primed of 2 also equals 0, so we remove that from there. So this can be simplified into this form. We know it equals 1, and from that we can deduce that f primed of 2 equals f of 2. So we have D. So that's D, and that's because we are told that fx minus f double prime of x equals 0 for at least one x. And we've shown the one case here. Now we can actually show that A is true, so this is A here, and the reason for that is we're told that f is a function that's always greater than 0. We're told that here in the question, and from that we can write, okay, f of x is greater than 0. We know then that f2 must be greater or equal to 0, and from that we can say the second differential of f must therefore also be greater than 0, and so we can deduce that fx has a local minima at x equals 2, and that's just by looking at the condition for local minima, maxima, for a given function. So cool, we also have A. That question I really liked. Okay, next question. A and B, they're on the reals. We have that the square of them does not equal 0. We have this value for S, where we know what the imaginary number is. We know that Z is a complex number, and it says, okay, well then X and Y must lie on one of these. So all we do is we start by saying, okay, we know that Z is given by a complex number. You can rewrite the complex number in this format, and that's because we are told it here. Okay. And you can rewrite that and say, okay, well then A plus I bt can also be this form here. Rationalise it using plus minus the complex number, and you can find that A is this value here and bt is this value here, and all you do from there is you can rearrange this to give you this value here, which means that the centre must have this value here, radius this value here. So we know that A is correct. B obviously isn't correct, and then it says for A not equal to 0 and B equal to 0 for C. So if we look at when B equals 0, we have Y equals 0, which means XY does lie on the x-axis, so this is true. And then if you do the same for A equals 0, you get X equals 0, so this is also true. So you end up with A, C and D. Okay, cool. Again, really quite a simple question, but really nice. Yeah, I really liked it. Okay, 2 questions left of section 2. We have that A, lambda, mu belong to the reals. We have this system of linear equations, and we're asked to deduce which of the following statements are correct. So, first things first, let's just write the system of linear equations. Now, we can immediately look at the determinant of this system, which is given by this here, and we can deduce that it's minus 2a minus 6. So now, if we look at when the determinant equals 0, then we know that the determinant equals 0 when a is minus 3, which means that if a does not equal minus 3, then we have unique solutions for all lambda mu. So that means we have the condition B. Okay, now we can look at the system of equations. We can rewrite them in a form that looks like this, and we're going to say when a equals minus 3, then from this we can say that lambda plus mu equals 0, and that must mean that there are infinitely many solutions just by looking at the system of equations here, so star. So that means we have C. Now for a equals minus 3, lambda plus mu does not equal 0, and so we have no solutions. So we can deduce that B, C and D are all correct for this question. Okay, cool, that's that question. Now the last question in this section, so we have these 2 functions, f and g. The functions are defined such that f of x is given by this here and g is given by this here. Now y denotes the greatest integer less than or equal to y for y belonging to the reals. Firstly, we can look at the condition for f of x here, and we can rewrite that in terms of this here. And if we look at the values for f, what we know from where the interval is for f, given by this in the question, the interval values are given by these here, and that is at the values of these values of x here. Now, if we were to draw this graph, we'd end up with something looking like this. Now you'll notice you have these jumps, which means that if you look at this graph, you'll note that the only time it's continuous at all is here, and that is for x equals 0. So x equals 0 is this line here, and that's the only time there's a continuity either side of x equals 0, whereas everywhere else, if you look at the values here, there's no continuity from this side to this side and so on between the rest. Okay, so we can say that f is discontinuous at 4 points, which means a is not correct, b is correct. Okay, now we go on to the bit more tricky part, which is the value for g, which is given by this in the question. Now if we do some similar manipulation to what we did earlier with f of x, we can kind of simplify this a little bit. So we can simplify it into this format just by expanding out the values, substituting in for what we had here earlier, and then again you can collect terms that are similar into this equation here. Now the important points on this function are, as before, we have these values here as we had in the first part of the question, so for the f value, and then we also have this additional value here, and that's just because we have this 4x minus 7. Okay, now I've just forgotten to add in here, we should have also had a 2 as well, I've just noticed. There should be an extra 2 in there. I was wondering why I'd just removed this 2 from here. Yeah, so we're looking at all the previous points that we had in addition to 7 over 4, and again that just comes from this here. Okay, so what you can do is you can look at the value of g of x for each of these points. You can find this here, and this gives you what g of x looks like for each of the different points. And from this we can deduce that g is not differentiable, and I should have said, and it's not differentiable at these values here. So at 0, 1, root 2, and root 3. Okay, so therefore we have that C is correct and D is not correct. Okay, cool, so that's the end of section 2. Let me know in the comments whether you preferred section 1 or section 2. And we now move on to section 3, which are basically you have to answer questions based on a paragraph. And it tells us that football teams T1 and T2 have to play 2 games against each other. It's assumed that the outcomes of the 2 games are independent. That's important. The probabilities of T1 winning, drawing and losing a game against T2 are these values here, respectively. Each team gets 3 points for a win, 1 point for a draw, and 0 points for a loss. Let X and Y denote the total points scored by teams, respectively, after 2 games. Okay, and the first part of the question says, we need to know the probability of X is greater than Y, and what is it? So, what I've written down is if X is greater than Y, so X and Y denote the total points as mentioned in the question. So therefore, if X is greater than Y, then there must be a win-win, a win-draw, or a draw-win. And you can look at what the probabilities of drawing and winning are, and if you just add some brackets around these here, you can substitute the values for that in, and we get 5 over 2, which means, so B is the correct value. Okay, now P of X equals Y. Obviously, if X equals Y, then that means we must have the equal number of points. We have win-lose, lose-win, or draw-draw. Okay, and again, if you just substitute the values for what they are, multiply them together, we get 13 over 36, and that's C. Okay, now as that paragraph goes, I thought that was really, really nice. I don't know whether, I'd love to hear from some of you that have done the Jee Advanced. Is there a heavy element of statistics at all? Because it's crazy, when I did my A-levels, which is similar time to when you would do this paper, we had kind of gone into a bit more detail on statistics. I just wondered whether the Jee Advanced focused more on maybe just mathematics rather than statistics, because it was more engineering focused. Yeah, I'd love to know. It's really interesting, but I really like this question. The question says here, let F1 and F2, which are at x1, x2 and y equals 0, for these values of x, be the foci of the ellipse. Doing some geometry here. And it says, suppose a parabola having vertex at the origin and focus at F2 intersects the ellipse at point M in the first quadrant point N in the fourth quadrant. So the first thing that I did was I just drew this. I just wanted to visualize it, as always. So what I did was I drew the ellipse, as you can see here, and then I drew a parabola, which is given by that there. And we know that it intersects this ellipse at the first quadrant and the fourth quadrant. And then we can look at where the foci are, and I just added them on as well. Now, a lot of the time in mathematics, when it's these kind of questions where it's kind of geometry related, I always find it easy to visualise. Yeah, makes things so much easier. So anyway, so I visualised it, and what we can do is we can first look at the formula for the foci of an ellipse, and we have this here. So the foci of an ellipse is given by this here, and that's just by looking at the equation for the ellipse itself. So we can say that then you have, this is minus 1, 0, and that's 1, 0, okay? Therefore, we can say the parabola itself is given by this equation here, and that's just by considering the foci of a parabola. So again, this is, I just really like this question. I think it's really intricate. I don't know, it's nice. You kind of got to remember certain different things. So anyway, so we know what the equation is for the parabola, and that's because we know what the foci are given for that given parabola and for the ellipse. Then all that we do is we just solve these two equations against each other, so the ellipse and the parabola, and we want to look at where they intersect. And that's pretty simple maths. You end up with a quadratic here. You can end up finding the solutions, and we know that you have a plus solution and a negative solution. We know the parabola is on the first and fourth quadrant, so therefore we arrive at these solutions here. So we have what x and y are, and that means we know at the point at which they intersect. Cool. Now this is going to help us. I just realised I haven't actually mentioned what we're asked to find. We're asked to find the orthocentre, so this itself is going to help us calculate that. So what we do is, we know that the orthocentre is going to look like this, because that's what it's asking us to find. And all you really need to do is just look at the graph that's formed between m, the focus 1, and n. Then we look at the equation of altitude. We arrive at an equation like this, and then all we do is we set y equals 0, which gives us the value for x, and then we get the orthocentre is this value here, so A. So the very final part of the question says, if the tangents to the ellipse at m and n meet at R, and the normal to the parabola at m, sorry, I should be highlighting this, meets the x-axis at Q, then the ratio of area of the triangle MQR to the area of quadrilateral MF1 NF2 is given by one of these. So the first thing that we can do is we can calculate the tangent to the ellipse, which gives us this value here, and then that is just substituting in the values for x and y that we found at which intersect. So we know the tangent at the ellipse, then we just sub in the value for y equals 0 and x equals 6, because we're looking at when it meets the x-axis, and therefore we deduce that r is 6, 0. Now again, we can do similar and find the normal at the parabola. We get this value here, we substitute y equals 0 in again, and we get a value for q, and then all that's really left to do is just look at the triangles that are formed by MQR, this quadrilateral here, and that is just some simple geometry, basically. You find that the area of MQR is given by this here, the area of MF1 and F2 is given by this here, and then when you calculate the ratio, you get 5/8, and so C. So C is the answer here. Okay, cool. So that is the entire of a G. I want to say G, but I think it's J. I've been saying J because I think that's how you can pronounce it. But anyway, so, well, that is the full Jee Advanced paper from 2016. But I really enjoyed doing this paper. I realise I have skipped over some steps. I'm going to be doing some videos on some of the hard questions from this section, and I'll be going into a lot more detail. So if you are interested, I'll put up my solutions somewhere that you can access and take a look at them if you're interested. But thank you so much for everybody that recommended me doing this paper. If you have any other mathematics exams you want me to sit, comment them down below and I will make a video on it. But thank you so much to everybody that supports my channel, and thank you for watching this video. If you liked it, please give it a big thumbs up, subscribe down below, and I'll see you all in the next video.